For most of human history, when we looked up at the stars and wondered what might orbit them, we pictured variations of our own backyard, maybe a bit hotter, maybe colder, or massive swirling gas giants, much like this one. But science had no proof. That is, until the early 1990s. With new instruments observing the cosmos, astronomers finally confirmed the existence of exoplanets. We realized our solar system was not alone in the dark. The data these telescopes returned challenged our tidy expectations. Instead of finding familiar cousins to Earth and Mars, astronomers found thousands of alien worlds with chemical and physical properties that fall far outside our previous planetary models. We are leaving the comfort of our own solar system to explore the most terrifying and bizarre worlds NASA has ever documented. To understand exactly how these places function, we have to look past our Earth-centric bias and examine what happens when the standard rules of thermodynamics and gravity are applied to the most volatile environments in the universe. Located roughly 750 light-years away, inside the constellation Draco, is TRES 2b. It is a giant gas world that reflects less than 1% of the incoming starlight. Fresh asphalt appears bright compared to this place. This atmospheric diagram shows why. Instead of reflective clouds, extreme heat creates dense layers of sodium vapor, potassium, and titanium oxide. When incoming starlight strikes these layers, the chemicals absorb it with brutal efficiency. But a lack of light does not mean a lack of heat. The planet hovers near 1,000 degrees Celsius, hot enough to melt aluminum. It is a nearly invisible inferno, glowing a very faint, dull red against the vacuum of space. At the opposite end of the spectrum, we find worlds like LTT 9779b, which acts like an ultra-reflective cosmic mirror, or the bright, almost entirely pink hue of the newly formed GJ 504b. And if you push the thermal limits even further, you reach Kepler 70b, a planet baking at temperatures so severe its surface heat easily rivals the outer layers of actual stars. Using the transit method and spectroscopy, when a planet crosses its host star, starlight filters through the atmosphere, projecting a distinct spectrum. Notice how readings drop at specific points. Elements block specific wavelengths. These gaps provide an exact chemical fingerprint, revealing compounds like titanium oxide. A planet's atmospheric chemistry dictates its entire relationship with light and heat, allowing it to become either a blinding reflection or a void of absolute darkness. Temperature also dictates movement. On K2-141b, the familiar evaporation and precipitation of a water cycle is replaced entirely by stone. Here, the heat causes entire mountains to vaporize into atmospheric gas. Supersonic winds carry these vaporized minerals across the planet to cooler zones, where they condense and plummet back to the surface as showers of molten rock. For extreme kinetic energy, scientists look to the violent atmosphere of WASP 127b. The winds tearing across this giant planet race at roughly 20,000 miles per hour. That is fast enough to circle Earth in less than 60 minutes. The atmosphere whips around the planet so fast that it outruns the actual rotation of the world itself. Instead of high-speed dry storms, other planets drown in pressure. GJ 1214b is a steamy water world where extreme atmospheric mass compresses water into exotic states of dense, glowing hot ice. Deprived of a gentle thermal balance, atmospheric fluid dynamics simply weaponize the available elements, turning them into supersonic walls of force or rains of liquid fire. The sheer mass of a host star also turns gravity into a destructive weapon, subjecting planets like WASP 12b to a slow cosmic execution. This models the massive tidal forces. WASP 12b orbits so close to its star that gravity stretches it into an egg shape. Billions of tons of material are ripped away every second and funneled directly into the star. Gravity can be highly constructive, too. We consider Saturn's rings massive, but the planetary body J1407b possesses a custom-built ring system over 200 times larger. Yet gravity's most extreme act might be total isolation, leaving planets like PSO J318.5-22 completely abandoned. This rogue planet does not orbit a star. During its formation, scientists suspect severe gravitational chaos violently ejected it from its home solar system,
throwing it out into deep space. There is no sunrise or daylight here, just endless cosmic night. But it remains a lonely furnace, still radiating hundreds of degrees of internal heat, trapped beneath its surface during its violent birth. We find these dark objects through gravitational microlensing. As shown in this diagram, when a rogue planet drifts in front of distant background stars, its mass bends and magnifies the starlight around its edges. Gravity proves to be the ultimate architect in space. It can construct immense ring structures, tear whole worlds apart, or exile them into the dark. Pulling back from the extremes of deep space, our own blue planet comes into sharp focus. The thousands of exoplanets NASA has cataloged reveal an uncomfortable statistical reality. The violently chaotic worlds we just toured are not the anomalies. We are. Documenting these brutal environments is crucial. They show us the absolute boundaries of physics, mechanics, and chemistry, mapping exactly how planets form and die. It highlights the extreme fragility of our environment.
A world with gentle liquid water, moderate winds, and a stable sun is a delicate configuration. The wider universe operates with profound violence. Our solar system is not the standard template for planetary physics. It is simply a quiet, miraculous sanctuary.